All right, so combinations and permutations. This is conditional probability number 2. Combinations and permutations. Say combinations.
Please excuse this interruption. Please disregard the bounce. It is a false alarm. Once again, disregard the bounce. It is a false alarm. Thank you.
And then everybody say permutations.
Permutations.
They're a little bit strange words. I guess combinations we have for things, right? Combination of my locker, or the combinations being things that add up together. But these are statistics terms. Permutations, I don't think we use in anything else except for statistics, but I could be wrong. So these are sort of an interesting idea. If we arrange a given set in as many ways as possible, how can we calculate the total number of ways that are possible? Here's an example of a combination. Draw out a smaller group from a larger group, and order is not important. Okay, so they use weird language in statistics a little bit. They're talking about drawing out, right? So imagine a bowl full of, remember we said about a bin full of marbles, or a bucket full of marbles, something like this. We're drawing out, which means we're picking marbles out of the group. Make sense when they say draw out? I don't know about the wording, but that's what we use, okay? So draw out a smaller group from a larger group, and order is not important. So here's an example of what that means. Order is not important. In how many ways can a coach choose 3 swimmers out of 5 swimmers? So in this case, we don't care what order they come out. We just want 3 out of the 5. So here's your 5, and you pull 1 out. And let's make, I don't know if swimmers is really good. We should probably use colored marbles or something, right? We're going to pull out 3 colored marbles. So you pull out red, green, blue. In this case, order doesn't matter. Remember in permutations when it did? We were concerned with red, green, blue. We didn't want to see that combination again. Now it could be red, green, or it could switch blue, green, blue, and that would be a new set, right? In this case, it's not going to be a new set because order doesn't matter. So it's going to be smaller numbers than we did before, right? So in this case, we're going to take a combination. C means combination. N is the total number. R is the number we're drawing out. And the formula is n factorial. Everybody say factorial.
Factorial.
Okay, thank you, thank you. And then n minus r factorial times r factorial. So 5 is the total number in this case. And then 3 is being subtracted from 5, that's r. And r factorial here also. And we do this, get out your calculator. You should do one of these in a minute. Let's do one in a second here. But let's keep going with permutations without repetition and permutations with repetition. So in this lesson, we're putting together the combination. And by the way, the abbreviation for this would be, if n is 5, this would be 5, C, R would be 3 in this case. That's the way we state it. We know it's a combination, we know the total number is 5, and we know we're drawing out 3. So you'll see that notation. The P will stand for permutation. In this case, we have an example where 4 items are selected from a group of 9 unique items. How many variations are possible? This is a lot like the marble example from the last lesson, where we're drawing out 4 from 9 and say they're different colors. What are your different options? In this case, 3,024. And then a permutation with repetition. So say it's the word apple, right? In the word apple, how many different ways can the letters be arranged? So we're looking at moving the letters around. And because there's a repeating letter of P, if we just had 5 unique letters, it would be 5 factorial, which is a large number. But because 2 of them repeat, 1 can replace the other. So notice that this 2 factorial, the 2 P's, is reducing that large number by this amount and coming up with only 60 options. And then the number of variations when drawing out of a loop. So combinations, permutations. So here's the contrasting. What's a combination? The number of variations drawing a smaller set from a larger set. So drawing a smaller set from a larger set. And then permutations, the number of variations when drawing from a group, when order does matter. Okay, so those are like the summary of the whole thing. Get out your calculator and plug this one in. Get out your calculator, turn it sideways, and plug this one in and see if you can get the 10 figure. Let's do that before we go. Anybody not know where the factorial key is? What's factorial mean? What's 5 factorial mean? What's it doing in the calculator? If it's 5 factorial, what's it doing? What's the calculator doing? Yeah, it's going through the 1 times 2 times 3 times 4 times 5. And you might think of it in reverse. You might think of it as 5 times 4 times 3 times 2 times 1. Right? An interesting way to think of it. And it's multiplying that for you. Okay, did you put in 5 factorial? Did you put in 5 minus 3 as 2 divided by 2 factorial divided by 3 factorial equals? And did you get 10? Okay, I got a couple shakes. I got a couple. All right. Again, the Android phone is going to be easier than the Apple phone because you can use parentheses and it'll calculate it directly, which is really weird for me. I find it hard to believe that Apple can't make their calculator user friendly, since that's their claim to fame. Okay, did it not come out? What's happening? Okay, so what'd you do? 5 factorial. Good. Divided by. Now let's just do the math ourselves. We'll do 5 minus 3 is 2. 2 factorial. Oh, say equals. Now say divided by. The next one is 3 factorial. Equals. There you go. So the equals has to be done. Yours should be a little bit cleaner because it's the Android. Is yours working out? That should not matter in this calculation.
Oh my God. We're going to do 5
There we go. Parentheses.
Because 60 and then
2
divided
factorial.
by
Times. And the other one is 3 factorial. And close it in the parentheses and see how it gives you all in one shot. See how the Android works different than the Apple, Tiffany? Yeah. Okay, you got it. Did you guys get it?
yeah.
Repeat after me. Hey, did you do the hands? Nice. Thank you guys. You're the best. Okay, you get extra credit for that. Okay, yeah, you can stop.